Hi students, welcome to Preliminary Chemistry and the Chemical Earth video series. In this one we're going to be having a look at physical and chemical changes and really just introducing this last little section, or this fourth little section of this topic. So the first thing we want to look at is physical change, and a couple of important things. Hopefully none of this will be new to you, or at least maybe a long way back in your memory that would just dredge forward. So physical changes are changes that involve less energy, small amounts of energy changes. All change requires energy, but generally speaking with physical changes, the amount of energy required is small and it's usually fairly easily reversed. Importantly, in physical changes, no new chemical substances are formed. All we're doing is often moving the atoms, molecules, or particles around, pushing them around, changing their shape, changing their orientation, but not actually breaking and reforming bonds. Some of the changes that are part of a physical change are things like filtration. So when we separate certain substances, evaporation is another example of that. All we're doing is moving two things that are mixed together apart from one another. And that separation is one of the things that is indicative of physical change. Associated with that is often the changes of state. So when we're going from a liquid to a gas, for example, a certain amount of energy must be put in order to facilitate that change. But really all that's happening is we're moving the particles apart from one another. So they're still the same particles, but where they were sliding past one another in a liquid, now they're whizzing around independent of one another in a gas. Also, things like malleability and ductility to be able to shape different types of metals, for example, or to draw them into wires. This sort of thing is another example of a physical change. The shape changes, but the chemical nature does not. Where we actually form new substances, or we have to put in significant amounts of energy, is where chemical changes occur. This often involves the breaking and reforming of chemical bonds. Now, sometimes this is the case for physical change. Diamond, for example, has a very high melting and boiling point, and that's because there are no weak bonds within the diamond structure. They're all chemical bonds, and we have to break a chemical bond just to move those atoms apart from one another. Oxygen, on the other hand, exists as a diatomic molecule and is very easy, requires very, very small amount of energy for the individual molecules to be moved apart from one another. But when we actually break the bonds between the carbons and between the oxygens and reform them to form a carbon dioxide molecule, we've now got a chemical change, a completely new substance which has formed, a rearrangement of the chemical bonds that were there before. And there's a number of different types of reactions that we'll look at as we go through this particular course that are indicators or examples of chemical change. Creating new substances from, so complex from simple is what we get from a synthesis reaction, and the other way around is what's a decomposition. So synthesis is going from simple to complex. Decomposition is what is going from complex back to simple. Combustion is a type of chemical change where fuels are burned in the presence of oxygen in order to release large amounts of energy and often to create new substances as well, carbon dioxide, carbon monoxide, and water. The process of smelting in industrial furnaces is also an example of a chemical change. The key with these two is to try and understand what is happening at the particle nature. So again, we're going to be using the particle model as we examine some of these changes in a little bit more detail. Thanks for watching.